Hello boys and girls, so in this video we are going to start our discussion on tutorial 6 circular motions. So sebelum kita pergi kepada penyelesaian masalah yang berkaitan dengan circular motions, kita recap dulu ataupun kita recall balik basic idea ataupun konsep penting yang ada dalam nota tentang circular motions. Okay, so what is circular motions?
If an object is moving in circles, it's undergoing circular motion. More accurately, it's defined as the motion of an object along the circumference of a circle. The circumference of a circle is the length of this boundary which is curved. So if an object is moving along the circumference of a circle, we say it's undergoing circular motion.
Okay, so circular motion refers to the motion of an object along in a circular path. In a circular path, we call it as circular motions. And in our topic 6, we are going to focus on uniform circular motion. So what is meant by uniform circular motions is the motion of an object in circular path whereby it have a constant speed. The magnitude of v is always remain constant, but then the directions of velocity is continuously changing with time. See this one? The directions of velocity is keep changing as the object move in a circular path. So this is what we consider as uniform circular motions. So in order to understand and solve problem related to uniform circular motions, we have to understand the terms we use to describe uniform circular motions. So this is the terms we use to describe circular motions. We have angular displacement, theta. This symbol is called theta. Okay, so what is meant by angular displacement? Actually, angular displacement is referred to how far the object is rotated. How far is already rotated. Then we might relate the angular displacement with linear distance. Then we have angular velocity, omega. Okay, this symbol is what we call omega. So angular velocity. So what is meant by angular velocity in a simple way? Angular velocity is referred to how fast the object rotate. Berapa laju objek tu berpusing dalam circular path. That one you call angular velocity omega. Now we have linear velocity v, frequency f, and period t. So now we recall what is means by each of these terms. So let's say you have an object. This is our object. Initially dia berada di sini. So this is our reference line or the starting line. So what is meant by angular displacement theta? Theta is the angle that undergone by the object as it travel in a circle. So that one we call angular displacement theta. So the SI unit for theta is radian. So in physics, the unit that we use for angle is radian. So we might change the angle in radian to degree and also revolutions, whereby one revolution, satu pusingan lengkap, is equivalent to 360 degree or 2 pi radian. Okay, so kita boleh lakukan penukaran unit antara revolution dengan radian. Kalau kita nak tukar revolution kepada radian, kita darab 2 pi. Kalau kita nak tukar radian kepada revolution, kita bahagi 2 pi. Okay? Contohnya, saya kata saya ada, for example, I have 3 revolution. So, 3 revolution tu setara dengan berapa radian? So, kita faham, satu revolution ialah 2 pi. So, 3 revolution means 3 darab 2 pi. So, kita akan dapat 6 pi radian. Okay? This is how we do the unit conversion. Or, for example, I might have 30 degree. For example, I have 30 degrees. So, I want to change it to radian. So, I understood 180 degree is pi radian. Or 360 degree is 2 pi radian. So, what I'm going to do is, so the 30 degree I'm going to divide by 180 times with pi. So, I'll get in radian. So 30 degree in radian will be 30 over 180. So it will be pi over 6 radian. It will be pi over 6 radian. So we need to know how to convert the unit for angular displacement from radian to revolutions or from revolutions to degree. Okay? And then you will notice that as the object you will notice that when the object undergone certain angle, it travel a arc length of S. Okay? Panjang lengkuk ni, yang blinking ni, the arc length is what we call linear distance. You might relate with the radius of the circle. R is referred to the radius of the circle, and the angular displacement, whereby S is r theta. Okay? S is r theta. This is how we relate the arc length traveled by the object as it moves in a circle with the radius and also the angle undergone by the object. Okay? So that one is the first two terms we use to describe uniform circular motions. Then how fast the object moves in a circle is what we call angular velocity, omega, the rate of change of angular displacement over time. Rate means time. Okay? Rate means time, massa. So the angular displacement divided by time, you will get the angular velocity. How fast the object move in a circle. So the SI unit for angular velocity is radian per second. Anyhow, we might have other units to describe angular velocity, revolution per second or revolution per minute. Okay? So it's a vector quantities. Angular velocity is a vector quantities. Then we have period T. What is period T? Time to complete one revolution. So period refer to time to complete one revolution. Berapa masa diambil untuk objek ni complete satu revolution? Itu kita panggil sebagai period T. Okay? So daripada formula angular velocity, omega adalah theta over T. So anda perhatikan, bila kita complete satu revolution setara dengan 2 pi. So, satu revolution 2 pi. So, masa untuk complete satu revolution adalah period T. So, kita boleh dapat formula untuk period T. T is 2 pi over omega. 2 pi over omega. So, the SI unit for period is second lah. Understood lah, because period is time kan, masa. So, SI unit untuk masa adalah second. Then we have frequency, F. What is frequency? Frequency is referred to the numbers of revolutions. Numbers of revolution that completed in 1 second. Maksudnya, dalam satu saat, within 1 second, berapa pusingan anda boleh lakukan? Itu you panggil sebagai frequency. Frequency can relate with period, whereby the frequency is 1 over T. So the SI unit for frequency is hertz. Okay, for example, I say in 1 second, the object complete 5 revolution. So, in within 1 second, the object perform 5 revolution. Dia pusing 5 kali. So, I will understood that the frequency will be 5 hertz. 5 hertz. Itu maksudnya frequency. Berapa pusingan yang lengkap dalam tempoh masa 1 saat. 1 saat. Okay. Now we know that an object that moves in uniform circular motions, because it moves with constant speed, so it will cover the same linear distance as in each second of time. So how we determine linear velocity? If we recall the formula from topic 2, kinematics, V is distance over time, S over T. So class, complete 1 revolutions is equivalent to the circumference. You pusing satu pusingan setara dengan satu lilitan bulatan, 2 pi r. So the S is 2 pi r. Masa untuk complete satu pusingan adalah period T. So divide by T. So we get the the formula. So 2 pi over t actually is referred to angular velocity. So we can relate linear velocity with angular velocity. V is r omega. Okay, so we can relate linear velocity with angular velocity. So class, bear in mind, the velocity, the direction is always tangential to the circular path and is always perpendicular to the radius of the path. Okay, so your velocity is always tangential to the circle. Then in uniform circular motion, an object moves at constant speed, v. So the speed is constant. Then we might ask, is there any acceleration? Ada tak pecutan? Is there any acceleration for an object that moves in uniform circular motion? So class, an object that moves in a circle with constant speed, we have to bear in mind, even though the magnitude of speed is constant, the direction is continually changing with time. So, if we refer to the definitions of accelerations, acceleration is the change of velocity, the change in velocity over time. So velocity is a vector quantities. Thus, change in velocity will not equal to 0. There will be a change in velocity when we have a change in speed or change in directions. So, in circular motion, we find out that we have a change in direction. See, this is initial point. The direction of velocity is here. And this is the second point, whereby the directions already changed. This is the direction of the velocity. So, we can see obviously there is a change in velocity due to the changing in direction. And what change in velocity is v final minus v initial. So, when I rearrange the vector v final and v initial, I'll find out that this is the change in velocity. For object that move in circular motions, and this changing in velocity is always point towards the center. So when there is a change in velocity, so means that we are going to have accelerations. So it means that we have accelerations that always point towards the center. So is there any acceleration for an object that moves at constant speed for uniform circular motion? Yes, we have acceleration. Whereby the direction is always towards the center. That's why, because the direction of the accelerations is always towards the center, so we give it a spatial name. So we call it as centripetal acceleration, AC. So, centripetal acceleration is the acceleration of an object that moves in circular path, whereby the direction is always towards the center and the magnitude is equal to the square of the speed divided by the radius. This is the formula we use to calculate the centripetal acceleration. AC equal to v squared over r. Then we know that v is r omega. So if I put it in v squared, so r omega squared, so squared over r, so one of the r is being cancelled, so I will get r omega squared. So I can calculate the centripetal acceleration by using r omega squared also. Or I know that r, then r is what? R is, if I rearrange this one, v is r omega. So if I rearrange, so the r will be v over omega. So multiply omega squared. So one of the omega is being cancelled. So I will get v omega. So this is the equation we use to calculate the centripetal acceleration for an object that performs circular motion. And always bear in mind, the direction of this acceleration is always towards the center of the circle. Centripetal means center seeking. So arah dia sentiasa pergi ke center. So the direction of acceleration is always towards the center and is always perpendicular to the linear velocity. See? This one. AC is always point towards center and tangential to our velocity. Okay? Tangential to our velocity. So please remember the concept. Velocity is always tangent to the circle and perpendicular to the accelerations. The direction of acceleration is always point towards the center of the circle. Kalau nak pusing dalam circular motion, pecutan acceleration kita mesti selalu menghala ke pusat bulatan. Menghala ke pusat bulatan. Okay? So this is the concept we have. The first half concept we have for uniform circular motion. So